Right, we are all set up for another night of imaging. Thank you. In today's topic, we're going to be talking about imaging statistics that you find in NINA. Imaging statistics. Imaging statistics. Whatever software that you use to capture your images, whether it be Sequence Generator Pro or NINA or something else, you're going to come across a box that looks a bit like this. And in the box is a bunch of numbers. And for years, I didn't understand what on earth they all meant. In fact, I just chose to ignore it. Commonly in the trade, we call it eyeballing it. And I just look at the images that came in over the night, whether it be 5-minute exposures or 3 minutes or sometimes 15 and 20-minute exposures. And I just roughly guess, did it look okay? But knowing the stuff that's in this box is actually quite helpful. So in today's video, we're going to break it down into 3 different sections, and we're going to have a look at what all these figures actually mean. As per usual in all my videos, there'll be chapter markers so you can get to the bit that's most relevant to you if you don't want to watch the whole video and you just want to get to the point of what you want to know about. So we're going to split this into 3 sections because really the statistics on screen just show 3 things. They show information about the camera, they show brightness and distribution statistics, and then they also show focusing and seeing condition statistics. So if we move to the section first that is about the camera, which are these sections here. And so first up is width and height. And this just literally tells you the width and the height of your camera sensor. So in this case, I've got 6,252 pixels by 4,176 pixels. That's it. That's all it's telling you. And probably most of you already know the statistics of your camera. And in this case, if we multiply both of those numbers together, what we'll get is 26 megapixels, hence this being a 26 megapixel camera. The next bit relating to cameras on here is, again, something you probably don't need on screen, but it's useful to have there, is the bit depth. And in this case, it's a 16-bit camera. Which gives us 65,536 levels. So the graphic on screen might help explain this. With 16 bits, we've got a nice broad dynamic range of all of those possible 65,000 plus levels from black right up to white. If we were to only have a 12-bit camera, we'd only have 4,096 levels of brightness to choose from. Most cameras these days are 16-bit. You can still find 14-bit and 16-bit, and sometimes even 12-bit cameras out there. So the higher the bit depth, the better your dynamic range, essentially. And then there's the gain control, which you only tend to find on CMOS cameras rather than CCD cameras. Often in CCD cameras, it's there, but it's baked in and you don't have a control over the setting. And often you hear about unity gain, which is the best possible trade-off. And so it results in a less noisy image, but at the expense of having to take longer exposures. You can think of this like ISO on a DSLR camera. And often if you're playing around with a DSLR camera and you go and set the ISO quite high above 800, say ISO, you'll start to see noise in your image. I like to set my ISO and my gains quite low for a less noisy image, but at the expense of longer exposures. A higher gain helps to make the camera more sensitive, but it costs you in more noise. And the sweet spot is often the unity gain. So that's section 1 covered. Really, it's just information about your camera, which you probably already know. But it's useful to have, I guess, in a pane. So the second section I'm going to talk to you about today is brightness and distribution statistics. And these are the sections highlighted on screen that tell us information. So you've got the mean, the median, the min and the max. So let's take a look at the mean. The mean is the average pixel brightness across the entire image. So a high mean can mean overexposure, while a very low mean can mean your image is underexposed. And obviously on this camera where there's 64,361 pixels, that would be complete white down to 0, which would be black, And of course, you don't want to get too low with that. Say the mean here was showing 100 pixels, you're definitely underexposing. So a mean of 862 pixels, which is what's on screen, is a reasonable amount of pixels to be showing up. It's not too low, but it's also not too high. Don't forget that stars will be by their very nature being very bright, will affect the image as well. So if you've got lots of bright stars, like an alnitak in your image, then your median is automatically going to be quite a bit higher. So in short, you can use the mean to monitor your exposure levels. And I typically work around about 1,000 for a decent image. You can, of course, use the histogram as well to look at this, and you want it no further than halfway or down around about a third. The median is exactly what you probably learned in maths at school. It is the middle pixel value, so it should be fairly close to the mean, and it's just a different way of understanding the average. But so if you put all the pixels in order from lowest to highest, then the median is that middle pixel. Half are brighter and half are dimmer. So in our case, 869 on the median is exactly halfway. It can be a better indication actually than the mean of sky brightness because it ignores outliers like very bright stars. So the median in some ways is a better indication of the mean. I tend to think about the mean in terms of a quick rough reference and then look more at the median once I've got everything dialed in with autofocus. Next on our list is min and max. And again, related to brightness and distribution. So the minimum shows the darkest pixel in your frame. In our case, it's 605 pixels in brightness. If we hit obviously 64,361 pixels, then that means the pixels are fully saturated. Next, we start digging into the more complicated stuff with SD, or standard deviation. And that shows how spread out the pixel values are. So a higher standard deviation means more variation. In other words, possibly you've got lots of bright stars in the image, but maybe a dim nebula signal. So a wide, high standard deviation in an image might look like this, whereas a low standard deviation might look like this. And then you've got my favorite acronym, MAD, which simply stands for median absolute deviation. And it's similar to standard deviation, but it's less affected by the extreme values. It's great for judging the consistency of your background noise from frame to frame. And so what you're looking out for here is as low a value as possible. So use MAD to check your background and how much noise. Obviously, in more light polluted skies or where there's street lights where you're imaging, your MAD is going to be higher. In my case, the street lamps were quite low, and 89's not a bad value at all. Okay, and into our final section, section 3, which are figures about your focusing and your seeing conditions. So when it comes to focusing in Nina, we use HFR, which stands for half flux radius. There are other measurements that you can use, but HFR is the popular one. The smaller the HFR, the tighter that your focus is. So ours is 2.99. That's not that sharp. I have had it lower than that. It depends on your camera, and you do get used to your camera dynamics on this. I have seen HFRs as low as 1.5-ish before. Around about 1.53 is fairly typical. If you've got a HFR of 4 or 5, you're probably slightly out of focus. So this is what a star would look like where HFR is focused at around a lower number, and this is what a star would look like if your HFR is too high. And then you've got the HFR standard deviation, which just shows how consistent star sizes are across your image. It's a little bit like the other standard deviation, but it's just purely focusing on the stars. A high standard deviation might mean tilt or bad seeing or field curvature In our case, 0.41 is not too bad. So what you're aiming for here is to have a low HFR standard deviation, which will mean that your stars across your image are all nicely focused. If you've got a high HFR standard deviation, then that might be indicative that some stars are focused while others are not as well focused. And then finally, we've got stars with the hashtag. I love that. It's like you're texting someone, hashtag stars. But all that means is the number of stars that the sensor has picked up in your image. In our case, 641 pixels have been picked up. And this does depend obviously on what you're imaging and how dense the star field is. But it's a good indicator of whether you're exposing for a reasonable amount of time, or whether the seeing is good, or whether the clouds have rolled in. Anything around 600, 800, 1,000 stars is normally typical for me. Obviously, if you're under really dark skies, that can hit well into the thousands. So keeping an eye on the stars can be useful, because if that number starts to decrease, it's a sign that you might have high altitude cloud creeping in and you may not have even seen it. So it's worth keeping your eye on that statistic. So that's it. Those are all your statistics, and that's what they all mean in NINA. And like I said, you get similar statistics to this in other imaging processing packages. Please comment in the sections. Please subscribe. I hope you've found today's video useful. My name is Martin. This is Adventures in Astronomy.